All right, because we have great reference, by the way. Yesterday I was chasing Henry around. He was Lightning and I was Jackson Storm, so it was a lot of fun. Anyway, back to class. You've never seen Cars 3? Oh, dude, you haven't lived. Now, what I want to focus on today is it's the same exact thing as yesterday. So I want you to tell yourself that right now inside your head, it's the same exact thing as yesterday. Same exact. All right. But now we're doing a chi-square test for independence. All right. So now we have two variables that I care about. Your dominant hand and your eye color. And we're asking ourselves, are they independent or is there a relationship between the two? So let's look at the null hypothesis. The null hypothesis is that there's no relationship, or in other words, that they are what? Independent. So that's always the null. So you should always use this for the null. All right? Make sure you put it into context. Handedness and eye color are independent. When we do the Inspire button pushing today, it'll look exactly like yesterday. We're going to make a matrix, use the chi-squared two-way test to find out our conclusion. So exactly like yesterday. Now, what's going to be hard on Tuesday, guys, when we do the Kahoot that I've already made, that is fantastic. What is challenging is knowing when to use which test. So when you're on the AP exam or you're doing a test in a couple weeks in this class, if I say, is there a relationship between these two variables? Is there enough evidence that there's a relationship between them? That is what I'm talking about. Chi-squared test for independence. So something about independence, relationship between two categorical variables. That's when you run this test. All right, let's keep going. You know the assumptions and conditions. We've been doing them. It's all the same as it's been. We're going to go super fast. You'll notice again we did the 10% condition where I multiplied the sample size of 114 times 10. This is a college course. Most colleges are over that many students. Now, while you're writing down, do you think there is a relationship between someone's eye color and their dominant hand? No. Okay. Maybe? No. Well, based on this data, we're going to determine if we think that's true for this. Science says no? We're just saying courses now? Quantitative analysis. Linear algebra. Algebra 2. You guys are really making this recording worth it. Okay, Vincent, we got it, man. Okay, do you guys remember the counted data condition? I just want you to check to make sure these are categorical variables. All right? So handedness, what are the categories they could be? Left or right. And then for eye color, what was it? Blue, brown, other. Yeah. I still have yet to teach a student that has a different color eye. Like each eye is different color.
You never taught Gabriel Adams?
Did he have different? Yeah. I did teach Gabriel. He did. Oh man, I completely forgot. How's he doing? Do you talk to him? Oh, nice. And now is it Fairview? And I think that's where his sister wanted to go. I wonder if they're both there. Cool. What was her name? No, Gabriel and what was her name?
Lee.
Lee! Yes, Eduardo for the win. Yes. Thank you, Eduardo. All right, now sample size assumption. We have to do the expected cell frequency condition. Who remembers the formula you could use from yesterday? No. That's chi-squared. Row total. No. That's degrees of freedom. Row total times column total over grand total, like the total number of people, 114. So let's just show you how you could do it for left and brown, the first one. You could do, what is the row total? What's 6 plus 36?
6 plus 36. 40.
Okay, wow. Times, what's 6 plus 7 plus 6?
13 plus 1.
My goodness, people.
Yeah, you speak too fast.
I'm just trying to write P now. Let's rotate it. There we go. So 42 times 19 divided by 114. If you did that in your calculator, you would get 7.
Wow.
Now, what would I recommend doing to find the expected values? Using the calculator. We're going to create that matrix. Okay? So you can obviously use that formula, row total times column total divided by grand total. And I will say there's a chance that it'll come in handy on the AP multiple choice. But for the most part, when you're running the actual test, you're going to want to use a calculator. Now, what do you notice about all of those expected values? What do I care? What do I care about? They're all 5 or above. Very good. So I'm not worried about our sample size. Okay, we're ready for the calculation of chi-squared. This is that formula for observed minus expected squared over expected. And you'll notice the degrees of freedom is identical to yesterday as well.
So for that last one, we have to do the statement, right?
Yes, you need a statement. Nicole's right. You want to make a statement. All expected values are 5 or above. Kevin, really? All right, so here's the calculations if you'd like to see. Now, while you're looking at those, I'm looking at the second table. I don't really have a chi-squared value that's jumping out at me. The largest one I see is blue and left. There were more left-handed, blue-eyed people than we expected. But only by 1.5, so that's why it's still pretty small.
Do you like your eye color?
Do I like my eye color? I mean, yeah, I guess. I like my sight more than my eye color. You don't like your vision? I have 20/40 vision. No, probably 2100 vision. The worst one. Do you wear contacts? What's your minus number? No, Nicole. Mine's.
I have classes in second grade and I have like astigmatism and like something wrong with my, like I can't see things look away.
But do you have, like, when you wear contacts, is everything good? No. It's still not great? I was like, maybe we should seek a different optometrist. I still remember the first time I wore glasses when I drive at night. But I wear contacts when I play sports. And I wore contacts and glasses when I first got them when I played baseball when I was 16. And I remember you could see the actual seams on the baseball. And I was like, oh, this makes hitting a lot easier. I remember the first game I hit a home run. I was like, man, should have done this a long time ago. And now, now I'm a professional baseball player, so it worked out. All right? All right. Are we good on the calculations? And you'll notice when I show you the answer here that it is not a very large chi-squared. The chi-squared didn't even eclipse 1. And then you should see, look at that p-value. 0.7? That's massive. That's huge. And not in like a good way. That's very high. All right, remember we want our p-values to be tiny. Very small. That's not a small p-value. You'll see when we shade, you're basically shading all of it. So you'll notice the conclusion is we are failing to reject the null hypothesis. There's not a relationship between handedness and eye color. We're going with that they're independent, which is what you guys thought initially, that there's no relationship between eye color and your dominant hand. Exactly. Science wins. Can I get a time check? No, I mean like how much time before the bell rings?
Like 5 minutes.
But I don't want like. I want it. We live at 42? Okay. Good. So we have time to do the inspire? I don't know why you guys are so mean about this. Then I guess I should get started then, Nicole. Jacob, whenever you're ready.
I have a question.
Yes. Did you just say, when did I meet my wife? Nicole, question? The King of Spain? No, I'm going to tell that story to my next class next year. No, I'm not. I don't want to see you next year. Not because I don't want to see you. I just, you shouldn't be here next year. You can come visit. There you go. Come visit. Nicole will actively come back to visit, but not seek me out. Got it. Fair enough.
Yeah. Be like, hi, I'm not here.
Well, you'll put a sign on the door, you'll hit it and be like, I want you to know that I'm here and I'm not here for you. Something like that. That'd be pretty good. That's okay. Did the inspire work? Yes! All right, let's do it. So if you're going to do this with us, you just need a calculator page. So just a blank calculator page. We're going to go to Menu, Matrix, create a matrix. How many rows? How many rows? 3 rows? How many? 2 rows?
No, 3 rows of columns.
All right. All right, give me the numbers. Hit me. 6, 36, 7, 26, 6, 33. Make sure you get outside the matrix. Well, that's the blue pill, right? That's the red one? Or the blue one? Just, okay, don't take pills? That's probably good advice. All right. Control, somebody said, wait, what? Was there a question? Just fine. Control VAR, so you can store it, and I just always use letter A. But if you want to use a different letter, like R for Roberto, go for it. Your R doesn't work. Oh, dude, I did not mean to be mean about that. I'm sorry. So we're going to use R. Menu, stats, stat tests. Now I know we're doing a different test than yesterday, right? This is a chi-square test for independence, but I'm clicking this. It looks identical to yesterday. It's still a 2-way test, and I have observed matrix R. You'll notice you see our chi-squared and p-value, which you already wrote down. All right, degrees of freedom was 2, and then hit VAR for stat.expected matrix to give you those numbers, which we already wrote down, and stat.computational matrix for the chi-squared values. Okay, I think I'm pretty confident that you guys can do the button pushing. The thing I would say you need to brush up on is make sure you know the assumptions and conditions, how to find degrees of freedom, how to write out the chi-squared, because you do need to show the work on how you're finding chi-squared for each cell. What? Literally the only thing different is the hypothesis. And your conclusion, right? Because the conclusion about if it's independent or not. But yes, Jacob, that's what's really nice about this.